Okay, number 19, I call this the lovely heart curve because if you're going to graph this equation, you are going to get a heart. And I did that for you guys right here. However, we are going to go ahead and take the derivative of this equation. Notice that the y is not isolated, so we are going to use the implicit differentiations to take the derivative to find out what dy dx is equal to. Let me write down the questions down here. X squared plus y squared minus 1 in the parentheses raised to the third power, and then minus x squared times y to the third power, it's equal to 0 right here. And now we're just going to focus on the equation rather than the heart. Okay, so let me just put down the notation to represent that we are going to take the derivative. So d dx and then across the whole equation. Now, let's see. For the first part, I have something raised to the third power. So as usual, I have to use the power rule. So I have to bring the power right here to the front and then minus 1. And we are going to get, let me write it down right here, 3. And the inside will stay the same. X squared plus y squared minus 1 raised to the 3 minus 1, which is the second power. And this is not it, because we have to multiply by the derivative of the inside. Okay, so derivative of x is, by the way, let's open the parentheses first to represent that this is the derivative of the inside function. The derivative of x squared is 2x plus the derivative of y squared is 2y, but then we multiply by the derivative of y, which is dy dx, okay, by the chain rule, and the fact that y is a function of x. So that's the first part. And then we're going to subtract x squared times y squared and find the derivative of this. And let me open the parentheses right here. And hopefully it fits. And derivative is 0 is 0, so it doesn't matter. And put down 0 right here already. Okay, this is the product of two things, two functions. So I have to use the product rule. The first one, which is x squared, and multiply by the derivative of y to the third power. So the 3 goes to the front, and I have minus 1 for the 3, so I have 3y squared. But then here we have y, so take the derivative of y, it's exactly what we got earlier, the dy dx. This and that, it's the same, and we are going to isolate them later on. So 3y squared times dy dx, okay, that's the derivative of y to the third power. Then we add the second function, which is y to the third power, times the derivative of the first. Derivative of x to the second power is just 2x. So that's pretty much it. And as I said, derivative of 0 is 0, so it doesn't matter. So this is the equation that we are going to work with right now. And the question is, which are the steps that we are going to do? We are to isolate dy dx. This is in the parentheses. I have something inside of in front of the parentheses. I'm going to distribute this in here and there for two parts. So it's going to look pretty long, but it's okay. So for the first part, I have the 3 times the 2. That would be a 6. And I have the x, so let me write this down as 6x. And this is pretty much stays the same. X squared plus y squared minus 1 to the second power. And then we'll take this and then distribute to the second part. So I add 3 times 2, which once again 6, but I have the y right here. And let me put this down first, which is x squared plus y squared minus 1 squared. And then the dy dx right here. dy dx. And for the second part, here I'm going to just distribute the negative sign inside of these two things and then arrange the terms if necessary. So I have minus, the 3 comes front first. The 3, let's put the 3 in the front first. And then x squared, y squared, dy dx. Right? And then negative times that, it's minus. Let's put the 2 in the front. And also the x first. And then y to the third power. that will be equal to 0. So far this is what we have. And now we are going to put our eyes on the focus of dy dx. We're going to focus on that. These are the only two terms that have dy dx. So I'm going to keep this right here on the left hand side. Keep these two things right here on the left hand side. So that means I'm going to bring this to the right hand side and also bring this to the right hand side. So the things that is going to remain on the left hand side is this. And since they both have dy dx, I can factor them out. But I will write it down as this. I'll put down this first, which is 6y x squared plus y squared minus 1 squared. And then I will subtract 3x squared y squared. And then put them in the parentheses. And then put the dy dx right here. Okay? And now we're equal to, let me bring this to the right hand side first, because this is negative right now. Once I bring down to the right hand side, it will become positive x, positive 2x, y to the third power. And then this right here is positive, bring to the right hand side, it becomes minus 6x, x squared plus y squared minus 1 to the second power. And one last step. To isolate dy dx, I can just divide by whatever I have in front of the dy dx, which is all that. So it's pretty much I just put all this under all that. So the answer is 2x y to the third power minus 6x times x squared plus y squared minus 1 squared, everything on the top, all over that. 6y x squared plus y squared minus 1 to the second power, and then minus 3x squared y squared. And that's dy dx. That's the derivative of our lovely hard curve. And now let's go back to the answer choices. And you have to just be really careful to see which one is correct. So A is not correct, B is not correct. I think C is correct, right? I'll double check. C is the correct answer. C is exactly the same as what we have. C is the correct answer. Okay, this is the lovely hard curve, the derivative of the lovely hard curve. Hope you enjoy it.